Alaikum warahmatullahi wabarakatuh. One of our experiments in the next lab will be based on the shift registers, and we will be making use of D flip-flop, and this is the complete circuit diagram, and I will be explaining in brief. All these are actually D flip-flop, and the output of the first flip-flop, you can see it is connected to the next one. Similarly, the output Q is connected to the D of the next one, and so on. And you can see that pin the reset pin is connected with some input. You can make it change 0 or 1. Okay, so it is possible to change during the simulation. Next, you can see that everything is given with a clock pulse. Each flip-flop is given with a clock pulse, and this clock pulse is having a frequency of 10 hertz. Actually, I have given a very small frequency to observe the output, what is happening. Okay, and similarly the clock pulse and everything can be monitored. And how I can get each module, that I will explain. For example, you can click here and place the component. And suppose if you want to place the switch or D flip-flop, D underscore flip-flop, you see you can get this flip-flop. So this is the flip-flop. Actually, now I am not using it. I have already connected everything. Then if you want to get the other component, for example, place the component, and suppose if you want to get the switch, for example, this is switch. Okay, so it is like a SPDT switch. That means a single pole double throw switch, and then you can click OK. Similarly, you can see that there are some other items like some probes are there. That means it will give you some like similar to some LEDs, that it will indicate whether the output is 0 or 1. That means you can use the probe. Okay, so this is probe. And what else is there is that you can see some clock pulse that you can give. So you can you can go to the sources. Actually, you can go to the signal sources, and from there actually you can give digital sources, and you can give the digital clock. And also you can get the ground. If you go here to the power sources, you can see there are different types of ground. You can take the digital ground and you can give here for the oscilloscope. Okay, and I think you know that oscilloscope you can take it from the right side. Okay, so this is the connection. Now I will be simulating this. You can see what happens. Okay, so if I simulate, you see there is the input I have given here, it is 0, and here it is 1. Next, if you connect it, you can see that this 1 is propagating throughout. Next, if you connect 0, then the 0 is propagating throughout, and for each part actually it is displaying this 0. Next, 0 0. Then the another way to show what happens if I give my input as a clock pulse with some small frequency. Let's see this. Okay, so I am going to connect instead of this direct inputs from the switches, I am just going to connect it by using these sorry for this, not this one. I need to connect the clock. Okay, so I will take a clock. So I will take my clock from here, then copy and paste. So the clock is connected here. Next, I will change the frequency to 1 hertz. You will see something very beautiful. The simulation is running. You see that it is becoming 1 1 1, then it will becoming 0 0 0. And what is the reason for this? You have to explain, and you have to write your observations in the lab report. Okay, so and also apart from that, I will show you what is according to the previous experiment, not previous experiment, previous part of this experiment. That means if I change it, I will just show the output. Okay, Now let's see, let me change the output, what happens. If I change, you see that the input has been changed from 0 to 1. Now you see the output has gone to 1, and everything, all these results you can observe, and you have to interpret the explanation. You have to give the explanation. I think this is clear to you. So hope we can see in the lab.